Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect of Elected. Today we're going to be looking at our first video in a two-parter that we're going to be doing on network security groups. Hi guys, today we're going to be looking at network security groups on Microsoft Azure and how you can use these to secure workloads on Azure. Now, network security groups provide some of the most fundamental kind of network security you can do, which is packet filtering. And so we are going to have to get our heads around the way that packets, IP packets in particular, work, and then we'll talk about how to use these properties of IP packets to secure your networks and your applications using network security groups at a VM level and then at a VNet level. So let's imagine for a minute that I have this image and I want to send this image over a network. So what I need to do then first is divide this up into chunks of data because this image is going to be too big to fit into a single IP packet. So I'm going to divide this up into various chunks of data, and then I'm going to take a single one of those chunks, say that center block with the cat's eye in it, and I want to send this piece over the network after I've sent everything else prior to it or something like that. Now, what I need to do that is wrap this in an IP envelope, and the IP envelope has on it 4 fields that are very important for packet filtering. The first ones are the IP addresses from the source and destination, and these are used by routers on the internet to determine how a packet will be sent from its source to its destination. Now, we're not going to get into how routing works, but these can also be used for filtering as well, so they will become important when we look at filtering. Also on that IP header is going to be the destination and source port. Now, the source port is typically in the upper range of the available ports on your system, and it's a 16-bit integer that basically denotes the source port that's sending it. It's typically up, 63,000 and somewhere up in that range, because those are typically used for transmitting data. However, the destination port is one of the more critical factors because it's going to be where this particular packet is going to be bound for. And port 80 in this case is HTTP. HTTP is very common on the internet. It's used by websites that aren't encrypted with SSL. In this case, if I'm sending it, it's probably some kind of upload that I'm doing to an HTTP-based server of a given image or file. So this basically will be sent to that, and it'll be received by the server. But probably before it gets to the server, it's going to traverse a firewall. And then based on the IP headers, a firewall can inspect the packet and then look for packets from a given source or destination and block the packet or allow it, or it can look at the ports and then allow it or block it too. And that's really the fundamental properties of a network security group, where it's going to be looking at packets to both filter it based on source and destination IP addresses, as well as the destination ports that are available that you can send a packet to. So let's go in and look at how these work at a IP level, and then we can kind of get an idea of what we're going to be looking at in our network security group as well. So when we talk about IP filtering, there's a couple of things that we need to consider here. One is the actual IP address itself. Now, this IP address is 192.168.0.3, and it has a subnet mask that's just for simplicity used 255.255.255.0. This would be very common on a small network, like something you might use at home. This determines how much of a given IP address is used for the network address. So an IP like this will use a 24-bit network address. So that means these first 3 octets, the first 24 bits of the address, are determining what part of this IP address is determining the network address that I want to use. And then the last 8 bits of this particular IP are used to determine the host address. So the two combined form a fully defined network address and host address, which is an IP address for a given system. Now, CIDR blocks, or CIDR, is used to determine something similar to that. It's not explicitly used to define a subnet mask, although it can be used for that. Subnet masks are typically used explicitly for the purpose of defining the part of a address that is the network address and the other part that is for the host address. CIDR blocks can do something very similar to that, in that you have a given IP range that is defined, and this is defining essentially the same thing as this IP address with this subnet mask, except this is really just defining a range of IP addresses. In the context of IPs, this is really what you're going to see more often is the CIDR notation, because it's not specifically bound to a subnet mask concept. That's a very subtle nuance, but the basic idea is the same. This one is just using a different notation. It's using 192.168.0.0, which is the first logical address that you could have inside of this IP range, although it's not the first usable address, which would be a .0. And this one then uses a slash and then tells me how many bits I want to use. So it starts off with the first logical address, which is this one, and then says, of this, I want to use 24 bits to determine the range of IP addresses that I'm going to include in this range of addresses. So this is going to tell me, start with this address and then include everything that is included in a 24-bit address space that would be included in this. So that would be basically 256 addresses, with this one being the first logical address, and then up to 255 usable addresses beyond that. So this would include this IP address as well. So it would be basically the same network that is defined by this IP with this subnet mask right here, but this is defining it using a different notation, which would include this IP address. So that's important to understand, particularly the CIDR notation, because you're going to see it a lot when you're just defining rules inside of network security groups. But the main thing to note is that this is just basically determining the number of bits in a given IP address that you want to include in your range. So if I did a /0, that's going to be the entire IPv4 space. If I did a /32, that's going to be a single address. And then you have a whole slew of addresses that you can have in between there. Most often it's going to be like a /24 or /16 or /20 or something like that. That's not going to include the entire IPv4 space. It's going to be some subset of that, but very rarely you're going to get down to like a /32 where you're doing a single IP address, although there are some cases that might be appropriate. So with that in mind, let's go and look at an IP filter and then demo that and see how that would look like in an NSG. So let's look at how packet filters work. So let's imagine I have this set of rules. Now, a packet filter defines rules based on the characteristics of IP addresses, like I mentioned, IP addresses and their ports. So let's imagine that I have a packet that has a source of 21.22.20.21.22.23 and a destination of 15.16.17.18. Those are my IP addresses, and the destination port is port 80. So this one gets sent across the internet, and then it gets allowed through because of one of the rules that matches it. And the way this works is it starts off with the first rule, evaluates it, and if the rules conditions match that packet, it will apply policy. This rule didn't match that particular packet. This one didn't, but this one did because the destination port was defined as port 80. And so it looked at the destination port. Okay, this is a packet match for this given rule, and then it applies a policy to it. So in this case, allow. This one is also doing a forwarder to a backend service, which is what we call destination natting. We're not going to get into that a lot today, but the point of this rule is that it allowed it based on the actual port number that was a part of that packet. So it saw that it was port 80 and allowed it through. And because none of these other rules matched it, it applied this policy. Let's look at another rule now. The other rule is this one right here. Let's look at this packet. So this one has the same source and destination as the last packet we looked at, but the port number is different. So this one would go to the firewall, and then it would get dropped because it would go through this rule list here. It would say that one doesn't match, that one doesn't match, that one doesn't match, and it would get down to this last rule here. This one does match because this is a catch-all rule. It says source IP any, destination IP any. So that basically says any packet is going to be included inside of this rule, and the policy applied here is blocked. So the way this works is a first match priority. So it starts at the top, and then it finds the first rule that it match it, and then applies the policy to it. That's why the first packet got through and the second packet did not, because none of these first three rules matched any of the criterion according to the rule, and therefore it got to the catch-all rule, which did match it and blocked it. Now, this is an important rule to have, a block all, and this is typically going to be found on any type of firewall that you spin up for the first time. You'll see a default rule that's going to block all traffic, and then you open it up as needed rather than start optimistically and say allow everything and then shut it down as necessary. You start pessimistically, block everything, and then open up the ports and IP ranges accordingly. Now, let's look at another one here. This one is our last packet here that we're going to look at. This one has got a source of 175.45.176.133 and a destination of 15.16.17.18 and a destination port of port 80. Now this one is going to hit the firewall and it's going to get dropped. Now, the reason that this one gets dropped is because of the source IP address. And this IP address range right here, the CIDR block, included that particular IP address range that was a part of that packet. So its IP fell into this range. So it got to this first rule, matched the criterion, and then applied the policy to it. That's why it got blocked. If it would have had a different IP outside of that range, it would have got to this rule and would have been allowed. Even though it had port 80, but because it got matched against this rule, it got applied first, and therefore it dropped the packet rather than allow it. So it's a first match basis on which packet rules get applied to a given filter, whatever that might be. So that's basically how a firewall based on packet filtering works. It just matches the first rule against a given criterion, and whichever one is the first match gets applied. If that's allowed, then it gets allowed. If it's blocked, it gets blocked. And this is how network security groups in Azure work as well. So it's pretty much a first match wins type scenario. It's a fairly crude way of doing it, but it's a very effective way because this is generally how any firewall, regardless of whether it's an NSG or whether it's a commercial oriented firewall or home-based firewall, are going to filter packets. And this is the common standard way of applying rules to packets as they come through a firewall that get filtered at that firewall. Okay, I'm here in the Azure portal and I want to show you network security groups now and how they're applied in Azure. Now, in my network security group demo resource group here, I have two network security groups defined. Now, the first one is a virtual network oriented network security group, and the other one is one that's applied to a virtual machine. So if I come down here to my network security group, this one is called VNet Network Security Group, and I click on it, I can associate a network security group either with a network interface card or subnet. So if I come over here to the settings for this, I can come over here to NICs and I can associate this one with a network security group. If this one didn't already have a network security group associated with it, I could associate this network security group with a network interface card that's attached to a virtual machine. I can also associate it with a subnet. So I can't apply it to the entire VNet, but I can associate it with a subnet. So in this case, I've got it associated with the default subnet on the VNet that my virtual machine is in. So this one is applying it to the IP address range. So anything that is on this subnet range 10.0.1.0/24 on this virtual network group will get the rules applied to it at the subnet level. So that means everything that is in my network security group, or rather in my subnet, will take advantage of this particular network security group that I have defined here. So that is the two layers in which a network security group can be defined. I actually have another network security group here that is associated with the network security card here. It doesn't have any associated VNets with it as well. Here's the one that's associated with the NIC card. And if I go into the network interfaces, this one's associated with the network interface card, and it's on the same subnet as the other one that's at the subnet level. And this one is associated with a public IP address. So if I wanted to apply specific policies to a specific virtual machine, I can do that at a given virtual machine level, and I can also do it at the subnet level if I so choose. This one allows me to have more fine-grained control at a VM level if I don't want to apply something more broadly. It allows me to define it more narrowly. So let's go in and look at the rules on these and see how these work. Okay, now let's look at some of the rules for these. Now, if I come into my network security group, this one's not connected to anything. I have a couple in here. This one is the one that's connected to my VMs. Now, if I look at this particular rule right here, this is the one that will allow SSH into this virtual machine. So I've got a Linux VM and I want to SSH into it. So I need port 22 open. So if I have that allowed, in theory, I should be able to connect to this, but I won't because of my other network security group at the VNet level. And this one doesn't have that rule available. So if I want to enable SSH into that VM, I need to have a rule at the subnet level, and I also need to have one at the virtual machine level if I have both applied. So if I try to do that, let's go back to my VM and let's try to connect to it. So I should be able to go into my virtual machine here. Let's go over here to my VM and then click on connect so I can get the SSH parameters here. There it is. Let's pull open a command prompt for PowerShell and let's SSH into this guy, or at least try to. And it's probably just going to time out or get some kind of a connection error where it is unable to connect because it's dropping the packet at the network security group that's attached to the subnet. So to enable this, I would need to add in a rule to allow port 22 on this particular subnet, and that would allow me to connect to this particular virtual machine by port 22. So let's do that. Let's come over here to on a VM though. Before I do that, if you come over here and you look at the rules that are applied, you might have the inbound rules set right here, and you can see the effective security policies right here under this. It kind of gives you a combined view of the rules that are applied at the subnet and the rules that are applied at the local network security group as well. And so this one will show me the inbound rules. So it's basically blocking everything. Inbound rules are available here. However, I've got another rule that is blocking it at the network here. So it's showing me the composite here. I don't have any rule here that allows that through. So that basically means that it's going to get blocked for this particular VM here. So to allow this, I need to come into my VNet network security group and create a rule, an inbound security rule on port 22. So I can come over here and define a rule. So if my source, I want to allow any source, but if I wanted to, I could filter the traffic based on a specific IP and port combination if I wanted to. But I'm going to say any's fine. We're going to get into application security groups and service tags in a future video on network security groups. But for now, let's just look at the ones that I can set up using IP addresses and the ones based on ports. So the source port range, I don't really care about. It can come from any source port. I'm not really concerned about that. I really just want to know the destination port, which in this case is 22. If I wanted to just do a range, I can use a dash, and that would allow port 22 to port 24 to through. But I'm only going to use a single port, and the destination can be any IP address, or I could filter it based on a specific IP address, which could be the IP of the VM. If I wanted to do a source IP address range, I could do that as well. So if I wanted to put the IP address of my particular network here, I could go, what is my IP, and I can get my local IP address, and I can plug that into this particular IP right here, and I can do /32 on it, which is a single IP address. Like I said, the CIDR notation, if I have /32, it's going to denote a single IP address. If I did a /something else /20, which I don't even know if that'll work, it's not going to let me, it's going to say use this instead because it's going to go down to the first logical address available in that /20 space. And it would then allow that block in, and then that would include the IP address that I am looking at here. But I'm only going to let a single IP address in, so a /32 source port range. I don't care. Destination port 22. So that's basically going to allow any computer that is coming from this IP address. So that could be practically anything on my network, because all of them are going to be coming out of that public IP address to connect to anything on port 22 on this subnet. And then I'm going to say this is just SSH inbound. If I wanted to allow any IP on the internet, I could just say any, and that would be fine as well. But I'm going to do it like this, so that if somebody wanted to connect, that was say my neighbor wanted to try to get into my Azure VM, they couldn't because their source IP address isn't that. So let's let this rule apply and then let it take effect. So even though it does create the rules, sometimes it takes it a while for it to propagate, and I will let that do that, and we'll come back when that's done. Okay, I've given it some time to propagate, so let's go and reconnect to our VM to see if it'll allow us through with this new rule. So let's come over here to our VM and get that IP arranged. I closed out my command prompt, so I'm going to get the IP address again right here. I'm just going to simply copy that, and let's launch command prompt, and I should be able to SSH into this guy now. So let's do SSH. And there it is. So yes, I'm going to accept this, and then I'm going to punch in the password I gave when I created this VM, and that should allow me to get into this. So you can see here that I'm into my VM. So I should be able to run commands like sudo -i and then do app.get update. Now, with this is actually going out to the internet. So say I wanted to prevent this VM from connecting to the internet. I just wanted to do things on a local context. To do that, I need to create an outbound security rule. So I'm going to come over here to my network security group, and I'm going to do it, let's say at the VM level. I want to prevent this particular VM from connecting to the internet. Now, notice that this one has allow SSH, and we did have to allow SSH at the subnet level, but I want to block this specific VM from accessing the internet. So to do that, I'm going to add an outbound rule, and I'm going to say source, that's fine. Destination, source port, that's fine. Destination, I'm going to use a service tag. I'm going to get more in depth on service tags and other types of things in future videos. But for now, the main one I'm looking for is internet, and you have some other ones in here, and we'll talk about what those mean in future video whenever we do a second video on NSGs. But in this case, I want to say internet bound, destination port, any. So basically any port, any destination, any destination port, any destination IP address that's internet bound, I want to block this. So any protocol, I'm going to set the action to deny in this case, priority 100, I'm going to say block internet. And that's the name of my rule. And then I'm going to apply that rule and then wait for it to create. And we'll come back whenever that's done. Now my rule has been added. Now this one actually conflicts with another rule that I have right here, but because this one has a higher priority, it's going to get prioritized first, and then it's going to get applied first. So this rule right here says allow internet outbound, and it's supposed to allow outbound traffic to the internet, but because this one has a higher priority, it shows up first in the list. The packets are going to get matched, just like we saw in our demo on the slide, that it's going to get to this packet, it's going to match it against the criterion of the packet header, and then it's going to then apply an action to it, or policy, in this case, deny. So back on my virtual machine, then I was able to run app-get update. Let's run that again and see if this will allow me to connect. So it's trying to connect now because I blocked internet access. It's not able to get out to the packet, the package managers for the particular virtual machine. And I can't access the internet because of that policy. So this machine is now has allowed inbound traffic through my SSH tunnel into this guy, but I can't reach out from this VM to the internet because I have an outbound policy that prevents it. So this is going to continue to struggle to get to the internet. Doesn't matter what I do. If I tried to ping, say, google.com, it's unable to reach google.com. I wouldn't be able to wget it. I wouldn't be able to get anything from the internet simply because I have a very draconian rule that's blocking internet bound traffic from this particular virtual machine. Now, if I was to remove that, of course, it would re-enable it. Even though I have this other rule that says allow it, it's prioritizing this one, and that's why I'm unable to get to the internet on this particular virtual machine. So you can see here that you can create rules at different levels. You can create them at the VNet level or at the NSG level that's applied to the subnet. So the VM can get the rule or the subnet can get the rule. But if you have inbound rules, they need to be able to clear both firewalls or both network security groups to actually get to the VM. And then it needs to be outbound. The same thing is true. It needs to be able to clear the local firewall for the NSG at the VM level, as well as the one at the subnet level as well, to be able to be accessing whatever resource is trying to get through with whatever packet it's trying to get through as well. So again, here's a very simple demo, but it does show you how you can set up rules based on destination ports, destination addresses, and source ports and source addresses based on IP-based information. In future videos, we're going to look at other ways you can do this in Azure using application groups, application security groups, as well as service tags, and we'll talk about what those are and how you can use those to more fine-tune your policies on network security groups for network security.
If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.